Okay, the first part of this question says use the factor theorem. You need to know what that means. That means you have to do it by substituting in what I call the magic value of x into f of x. If you try and do it by taking out a factor of 3x plus 1 and showing that it works, you'll get 0 marks because you haven't used the factor theorem. So you need to say f of the particular value, which will be the value that makes the factor equal 0, equals, you'll substitute that in, and you'll get the appropriate answer that enables you to conclude that therefore 3x plus 1 is a factor, and say of f of x. So always draw the conclusion on a show that question. Okay, then we've got to express f of x as a product of three linear factors. So now we do use the grid. So we've got a factor of 3x plus 1, and we know we're aiming for 9x cubed plus 18x squared, all of that stuff. So you do the grid to get 3x plus 1 times another bracket, and the grid should work out perfectly because we know this is a factor, and then this quadratic bracket here you factorize again. So this is actually the kind of thing you did in core 1. So you end up with three linear factors. Then we've got to simplify this. F of x on the bottom is just this thing which you've just put into three factors. So guess what? You're going to factorize the top as well. Because there's no constant term, there's a very easy factor you can write down outside a bracket. You've got another constant factor as well to take out, and then there's a quadratic to factorize, and you'll have at least one bracket, I would guess, cancelling with the stuff that you got from f of x. So that's part A. Alright, and then part B is independent. This is a re-entry point. You don't have to have done part A to do part B at all, I don't think. We've just got a remainder given when we divide by a particular linear factor. I mean, it's not a factor of this, but it's a linear bracket. So we have to use the remainder theorem. So just as with part A, there was a magic value that made the 3x plus 1 equal 0 that you substituted in to show it was a factor. Here for 3x minus 2, there's a particular value of x that we're going to substitute in, and we're just going to say the remainder that we need is this polynomial f of x was used in part A, so let's call this p of x. P of whatever value that is that makes this equal 0 is going to be your remainder. Okay, well, so we know the answer to that. We know what the remainder is, but we don't know this missing coefficient p. But when I substitute in the value of x, then p will be the only unknown in the equation, and I'll be able to solve to find a value of the constant p. Okay. I hope you don't mind that I've used p of x to mean the polynomial. Maybe I should have called this g of x. Okay, so maybe this is g of x here, and p is just a constant in that g of x.